Hi, hello everyone. Today we are going to see about the Lebesgue space. It is defined as LP of omega. The space LP omega. Omega be the domain. It is in the R power n. So P be the any positive real number. Be denoted by LP of omega. It's a class of measurable functions U and defined on a it's a class of measurable function. So it is defined on omega. It can be represented as integral omega mod u of x power p dx less than infinity. So we know that we have to know that Lebesgue space is less than a finite value. Okay, the domain, it's a non-empty open set that is in present in the R power n. So what is the measurable function? A function f is defined on a measurable set. We define a measurable function means it has to be defined on a measurable set having the values in between real r of union of minus infinity to plus infinity is itself a measurable. If the function itself is a measurable and f of x greater than a means that a belongs to real. So the set x such that f of x greater than a is measurable for all a belongs to real number. So it's a measurable functions. So from lemma we know from lemma 2.2 we have to show that if 1 less than or equal to p, it's a real number less than infinity, and ab that is greater than 0, then we have to prove that a plus p whole power p, a plus b whole power p less than or equal to 2 power p minus 1 a power p plus b power p. So if we put the value for p equal to 1 means, if p equal to 1 means a plus b, that is can be written as a plus b, and 2 power here 1 is 1 minus 1. So 1 minus 1 0, anything power 0 is 1, so it is a power 1 plus b power 1. So this condition is obviously true, so we no need to prove any of the terms. So we have to prove that if equal to, so if it is greater than 1 means if it is obey these conditions or not, we have to prove that. So for p greater than 1, the function tp is convex on 0 to infinity. We take the greater than 1, we have to assume that the function that is tp that is convex. Convex is nothing but if we draw a circle, if the two points are lies inside the circle means if we draw the line, if it is present in the circle, it is convex, or otherwise if it is one point is inside, another point is outside. So if we draw the circle, it will draw a line. If it is cut the circle means it is not a convex. So for p greater than 1, the function tp is convex on the domain of 0 comma infinity. So we have to prove that is, from this we know that this graph lies between the chord line joining the points of a comma a power p and b comma b power p. So what we have to do means we have to prove that we know that pi of x, we assume that pi of x is the convex function in r power r. So then for lambda belongs to 0 comma 1 means, because that lambda value must lies between 0 to 1, so we have to prove that pi of lambda x plus, this is the convex function, lambda x plus 1 minus lambda y less than or equal to pi of lambda of pi of x plus 1 minus lambda pi of y for all x comma y belongs to r. So we have to take that, we have to put that lambda equal to 1 by 2 means x equal to a, y equal to b. Okay, according to, we have to verify that a comma a power p that lies in this form, lies in the convex. So we take the convex definitions and we have to apply. So pi of a plus b divided by 2 is less than or equal to, we have to multiply the pi goes inside means pi of a plus pi of b divided by 2. The function is pi of x is x power p. So instead of we have a means whatever the phi inside, that must be rise power p. So here is a plus b by 2 whole power p means less than or equal to a power p plus b power. This is a power p plus b power p divided by 2. B, this is pi like x, so a plus b by 2 whole power p. So 2 power p getting cancelled, so it is a plus b whole power p less than or equal to this 2 sorry, this is 2 power p, so it goes here means 2 power p minus 1 a power p plus b power p, so hence the proof. So if u comma v belongs to lp omega, then u of x plus v of x whole power p less than or equal to 2p minus 1, that is mod of u of x p plus v of x p, such that u plus v also belongs to lp of omega. So lp of omega is a vector space. Hope you all understand, and thank you.